Let's look at example 29, and example 29 says cos of alpha minus beta plus cos of beta minus gamma plus cos of gamma minus alpha is equals to minus 3 by 2, and then you need to prove this cos alpha plus cos beta plus gamma is equals to 0, and sin alpha plus sin beta plus sin gamma is equals to 0. So how will you approach this question? What's the intuition that you should follow? In the question you can see it's cos of alpha minus beta plus beta minus gamma plus gamma minus alpha. So one very basic thing that we need to do is expand it. Open cos alpha minus beta, and in terms of sin cos alpha cos beta plus sin alpha sin beta. Now from here you have to think how to approach the given equation that we need to prove. So what can you do? You have cos alpha cos beta cos gamma cos alpha. Even if you try to take cos alpha common, you will get cos beta plus cos gamma one term. That is nowhere useful to this. One thing that you can see here is you have a plus b plus c here, let's say, and then you have the term ab plus bc plus ca. If you are seeing this, then one intuition that should straightforward come to your mind is, why can't I use a plus b plus c whole square? Because it will be a square plus b square plus c square plus 2ab plus 2bc plus 2ca, right? Now I'll tell you why you need to follow this intuition. Point number 1, you are seeing the term a, b, b, c and ca, and then you have a plus b plus c. The only thing that you don't have is a square plus b square plus c square. So why should you use this? Let me tell you. You are given one equation and you have to prove something in the form of x is equals to y is equals to 0. So this given equation will boil down into something which should be as x square plus y square is equals to 0, because in that case you can say that x is 0 and y is 0. Why? Because the square of any positive number, the square of any real number is either positive or 0, that we know. So here x also needs to be 0 and y also needs to be 0. So we are trying to get some kind of intuition कि we need to convert this whole equation into this square, something of square, and we will use this intuition, right? 2ab plus 2bc plus 2ca. So let's see what we can do. Another intuition is, you see you have a 2 term here. You can slide that down to left hand side. So left hand side will become, I'll quickly write down, now you will shift this right hand side to left hand side. Why? Because you also need to get the terms a square plus b square plus c square. Like somehow you need to have cos square alpha plus cos square beta plus cos square gamma plus sin square alpha sin square beta sin square gamma. So why not use this 3? How? Shift that 3 to left hand side. Now you can write 3 as sin square alpha plus cos square alpha, which is 1, then sin square beta plus sin square gamma, which is 1 plus 1 2, and then you can write it as, sorry, cos square gamma, sin square gamma plus cos square gamma, right? So take this 3 to left hand side and replace 3 by squares as I mentioned. So this will be, if I rearrange the terms, cos square alpha plus cos square beta plus cos square gamma. I'll write it down quickly. This equation is equals to the previous one. How? In place of 3 I have written cos square alpha plus sin square alpha 1, then this is also equals to 1 and this is also equals to 1, and the right hand side is same what was in the previous equation. So now I can see that it is in the form of a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So what I will write it as cos alpha plus cos beta plus cos gamma whole square, and in a similar fashion you can write these sine terms also. Sine alpha plus sine beta plus sine gamma whole square is equals to 0. Now the square of two real numbers is 0. The sum of squares of two real number is 0, which means each of them should be 0, right? So from here you can write that cos alpha plus cos beta plus cos gamma is 0, and sine alpha plus sine beta plus sine gamma is also 0. And that's what you needed to prove in the question.